Now as we get equation of hyperbola is x square over a square minus y square over b square. Now we get some conclusion on the basis of equation of hyperbola. So the next topic is conclusion. On the basis of equation of hyperbola. So the first one is on change of x to x and y to minus y, equation remain same, that is hyperbola is symmetric about x-axis, and on change of x to minus x and y to y, equation remain same, that is hyperbola is symmetric about y-axis, and on changing x to minus x and y to minus y, equation remain same, that is hyperbola is symmetric about origin. So this was the first conclusion. Now the second one, that is intersection with axis. Put y is equal to 0, we get x square over a square is equal to 1. That implies x square is equal to a square. That implies x is equal to plus minus a. That is intersection with x-axis is point A with coordinate a comma 0 and a dash with coordinate minus a comma 0. Now put x is equal to 0, that is minus y square is equal to b square. That is y square is equal to minus b square. As b is not equal to 0, then for no real value of y, y square is equal to minus b square whole. Thus, hyperbola does not intersect with y-axis. But in analogy with the ellipse, the point B with coordinate 0, B and B dash with coordinate 0, minus B are called vertices of hyperbola, but these points are not on the hyperbola. Therefore, AA dash, which is equal to 2A, is called transverse axis, and in case ellipse it is called major axis, and BB dash of length 2B is called conjugate axis, and in case of ellipse it is called minor axis. The hyperbola x square over a square minus y square over b square is equal to 1 does not intersect y-axis, but it lies on both sides of y-axis. Two parts of the hyperbola have no point in common, and they are called branches of hyperbola. In ellipse, we see ellipse is a continuous curve and it intersects x and y axis, but hyperbola has no common point of intersection and it has divided into two branches. One branch is on the right hand side of x-axis and one branch on the left hand side of y-axis, and one branch is on the right hand side of y-axis. So this is all about the conclusion, that is technical conclusion of hyperbola. Now we are going to discuss the third conclusion, that is a second pair of focus and directrix. So as we know, the equation of the hyperbola is x square over a square minus y square over b square is equal to 1. That means it gives x square over a square by substituting the value of b square, that is a square into e square minus 1 is equal to 1. So on simplification we get x square into e square minus 1 y square is equal to a square into e square minus 1. So on solving this, we have x square e square minus x square minus y square a square e square minus a square. That gives, we have x square plus a square e square plus we are adding aex plus y square is equal to a square 2aex plus e square x square. So from this we get x plus ae whole square. What we done? We done x square e square as it is plus a square here and we add both sides to aex to make it perfect square, and here x square plus a square e square and plus y square to make this term as perfect square, which is equal to x plus a whole square plus e square is equal to, if we see, we get ex plus a whole square. That is, from here we will get x plus a whole square plus y square is equal to e square common, and we get x plus a over e whole square. That implies we have finally x plus a whole square plus y square is equal to e square x plus a over e whole square. That is, so if s dash is minus a comma 0, another focus, and line L dash with equation of directory x is equal to minus a over e implies x plus a over e is equal to 0, then m dash be the foot of perpendicular from p of xy to L dash such that above equation becomes s dash p whole square is equal to e square p m dash square, that is perpendicular distance of p from the line L. Then we say the second focus is s dash with coordinate minus a comma 0 and second directrix, that is x is equal to minus a over e, exists for equation of hyperbola. Now the fourth conclusion is about chords, focal chords, as we have two focus, the focal chords and lettera recta. As we have two focus, so we have two latus rectum, so we call them lettera recta. It is a plural form of latus rectum. So in line segment, joining 2 points of a hyperbola is called a chord of the hyperbola. And if a chord passes through a focus, then it is called focal chord of the hyperbola. As seen in the case of ellipse and parabola. And a focal chord perpendicular to the transverse axis of the hyperbola is called latus rectum of the hyperbola. As hyperbola has two foci, then it has two latus rectum. That is latra recta. So it was the fourth conclusion of the equation of the hyperbola. Now the fifth conclusion is, as we know it has latus recta, then what about the length of latus recta? If we find the length of one latus rectum, then it is true length of other latus rectum is same. So we are going to find length of a latus rectum. Consider a latus rectum L1, L4 passing through a focus S with coordinate AE, 0, then the equation of L1, L4 is x is equal to AE. That is, coordinates of L1 is AE, y and L4 is AE, minus y. So first we draw the diagram to understand L1 and L4 position. So this is x-axis and this is y-axis. And we have two hyperbola here, branches. This is L dash and this is L, that is directrix. This is focus S, this is focus S dash. This is L1, this is L4 and passing through focus. And here a line passing through focus is called latus rectum. Name L1, L2, L4. as the equation of L1 is x is equal to a, because it is a comma 0, so x coordinate will be same and equation is x is equal to a. So coordinate of L1 are ae comma y at same or the equal distance, and below the y x-axis same distance, so ae comma minus y. So we have L1 and L4. As L1 lie on the hyperbola, therefore it will satisfy the equation, that is x square over a square minus y square over b square is equal to 1 becomes a square e square value of x over a square y is same y square over b square is equal to 1. That gives e square minus y square over b square is equal to 1. So we get e square minus 1 is equal to y square over b square. So that gives b square into e square minus 1 is equal to y square. Or we can write y square is equal to b square into e square minus 1, and value of e square minus 1 is b square over a square, because b square is equal to a square e square minus 1, that is from the standard equation of hyperbola. So here we get y square is equal to b raised to 4 over a square, that is y is equal to plus minus b square over a. Therefore, coordinate of L1 are ae comma b square over a, and L4 are ae comma minus b square over a. Similarly, coordinate of L2 are minus ae passing through focus x is equal to minus ae, comma lying on the above in the second quadrant where y coordinate is positive, that is b square over a, and L3 minus ae comma minus b square over a square. As we have L1, L4, L2, L3, so we can find out the length of lattice rectum. Therefore, length of lattice rectum is L1, L4, that is under root ae minus ae whole square plus minus b square over a minus b square over a whole square by distance formula. So we get minus 2b square over a whole square. It will give 2b square over a whole square, minus square is positive. So we get 2b square over a. So that is the length of lattice rectum of hyperbola. Now the last conclusion, that is sixth conclusion, is another form of the equation of a hyperbola. If we consider hyperbola with transverse axis along y-axis Then equation of hyperbola will be y square over b square minus x square over a square is equal to 1. And this hyperbola is said to be conjugate hyperbola of the hyperbola x square over a square minus y square over b square is equal to 1. So this was all about the conclusion of equation of hyperbola.